This is the full VS Code Agentic Development course explainer, not a roadmap. We are going lesson by lesson through the official Visual Studio Code learning pack, and for each lesson we will answer 5 questions: what the lesson teaches, why it matters, how to practice it in a real lab workspace, how to verify that you understood it, and what mistake to avoid. The official source is the VS Code Learn Hub and the Visual Studio Code announcement thread. The local lab workspace gives us a place to practice without pretending. Keep this structure in your head. Foundations teach control, customization teaches repeatability, and extensions teach capability. If you learn those in the wrong order, you get an agent with power but no operating discipline. If you learn them in the right order, VS Code becomes a controlled agent workbench. This video is not a watch list. We will teach the concepts behind every lesson, show what each feature is for, and give you a practical lab exercise for each. 1. The goal is to turn the reading pack into one coherent course you can follow with your own VS Code workspace open. Your first exercise is simple. Open the local lab workspace and keep notes/courseprogress.md visible. After every section, write the key idea, the file or command used, the practice result, and the verification step. The first proof is not a fancy app. You can explain why the official order is foundations first, customization second, and extensions third. Watch for the main mistake. Do not start by installing every tool and plugin. That gives the agent power before you have review habits. Lesson 1 of 18, Introduction to Agent-First Development. The official page teaches this. The official lesson teaches how harness, model, context, tools, prompt, and approvals work together. It frames agent-first development as a system where the editor, model, repository, and user review loop all matter. Here is the real explanation. The harness is VS Code itself: chat, workspace search, file editing, terminal access, diffs, checkpoints, and debug views. The model reasons, but the harness determines what it can see and do. Context is the selected files, workspace state, previous messages, instructions, and any attached sources. Tools are the agent actions. Approvals decide which actions need human confirmation. The prompt is not just a request. It is the contract that tells the agent the goal, scope, constraints, and success criteria. Now make it practical. Pick one tiny task in the lab, such as summarize the README and suggest one safe improvement. Before asking the agent, write down the required context, the tools it should need, and the actions you would not approve. Your verification step is this. Your checkpoint should name the harness, model, context, tools, prompt, and approvals in your own words, then map each one to the task you chose. The mistake to avoid: do not blame the model first. Most weak agent sessions come from missing context, vague goals, too many tools, or approvals that are either too strict or too loose. The 3 takeaways are: agent work is a system, not just a prompt. Good context and scoped tools shape the result, and approvals are part of the design. Lesson 2 of 18, your first agent session. The official page teaches this. This lesson explains tool call approvals, permission levels, autonomy, tool calls, and context window management for a first real session. Here is the real explanation. A useful first agent session is not fully manual and not fully automatic. You want scoped autonomy. Let the agent read relevant files, propose a plan, and make small edits, but keep risky actions behind approval. VS Code surfaces tool calls so you can see when the agent wants to read, edit, run, or fetch. The context window is the agent memory for the active session. If you stuff it with unrelated files, old instructions, and broad tool definitions, the model has to reason through noise. If you provide too little context, it guesses. The skill is choosing the smallest context bundle that can support the task. Now make it practical. Ask the agent to update one sentence in readme.md or add one note under notes/courseprogress.md. Use a permission level that requires approval for edits. Watch the tool calls and accept only the ones that match the task. Your verification step is this. Your diff should show a small intentional change. Your notes should record which tool calls appeared and which ones you approved. The mistake to avoid: do not grant broad terminal or external service access for a documentation exercise. Match permission to blast radius. The 3 takeaways are: use scoped autonomy, watch tool calls, and control the context window. Lesson 3 of 18, reviewing and controlling agent changes. The official page teaches this. This lesson covers the files changed bar, per change controls, editing a previous message, steering while the agent runs, checkpoints, restore, forks, and common review patterns. Here is the real explanation. The real power move in VS Code agent work is that the agent can act, but the human still owns the final state. The files changed bar tells you what changed. Per change controls let you accept or reject individual edits instead of treating the whole run as one block. Editing a previous message changes the instruction the agent is responding to. Steering while the agent runs lets you correct course before the mistake spreads. Checkpoints create a safe return point. Restore lets you roll back. Forking lets you explore a different direction without losing the current branch of thought. Now make it practical. Give the agent a small task with 2 parts, such as improve README wording and add one checklist item. Then reject one edit, accept the other, and write down why. If the agent chooses a bad direction, steer it mid-run with a tighter instruction. Your verification step is this. You can show the final diff and explain every accepted and rejected change. If you forked or restored, record what changed after that decision. The mistake to avoid: do not accept a large generated patch because the summary sounded confident. The diff is the truth. The 3 takeaways are: review is the safety loop, checkpoints and forks reduce fear, and the human owns the final diff. Lesson 4 of 18, agent sessions and where agents run. The official page teaches this. The official page explains the agent sessions sidebar, agent type picker, local agents, Copilot CLI background agents, cloud agents, handoffs between agent types, and how to choose the right agent type. Here is the real explanation. Not every agent job belongs in the same execution mode. Local agents are best when the task needs your current workspace, local files, and close review. Background agents help when the task is longer, but still scoped enough to run without you watching every token. Cloud agents fit tasks that can run remotely, such as issue-based implementation or larger follow-up work, but they need clean instructions and safe boundaries. The agent type picker is therefore a risk and workflow decision, not just a menu. Handoffs matter because a task may start as local exploration, then move to background or cloud once the goal is well specified. Now make it practical. Take 3 examples. Tasks: explain a file, refactor a small function, and implement a multi-file feature. For each one, choose local, background, or cloud, and write 1 sentence explaining the blast radius. Your verification step is this. Your choices should mention privacy, review needs, runtime, and whether the task has a clear success condition. The mistake to avoid: do not send vague exploratory work to a cloud agent. First, create a precise task and success criteria. The 3 takeaways are: execution mode is a workflow choice, local is strongest for close review, and background and cloud need clearer specs. Lesson 5 of 18, debugging agent work. The official page teaches this. The lesson teaches the agent debug log panel, chat debug view, debug event snapshots, troubleshoot commands, what to look for, and log persistence notes. Here is the real explanation. When an agent does something odd, the worst response is to shrug and say the AI was bad. Debugging asks better questions. What messages did the model receive? Which context was included? Which tool calls were attempted? Did a tool fail? Was a file unavailable? Did the model run out of useful context? The agent debug log panel and chat debug view make this behavior inspectable. Debug event snapshots help capture a moment in the run. Troubleshooting commands give you a structured path when the session behaves differently than expected. Now make it practical. Run a small agent task, then open the debug view and identify 1 piece of context, 1 tool call, and 1 decision point. If the result was wrong, trace whether the cause was missing context, tool failure, ambiguous instruction, or bad reasoning. Your verification step is this. Your checkpoint should include 1 debug observation that is not visible from the final diff alone. The mistake to avoid: Do not use debug logs as decoration. Use them to decide the next prompt or the next constraint. The 3 takeaways are: debug the process, not just the output. Logs reveal context and tool behavior, and a bad result often has a visible cause. Lesson 6 of 18. Build your first app with agent mode. The official page teaches this. The official demo builds a URL shortener with agent mode using Fast API, SQLite 3, planning, autopilot, review tools, context checks, iteration, and forking. Here is the real explanation. This lesson is not really about URL shorteners. It is about the end-to-end loop for shipping with an agent. First, choose the right model for the task. Then use a planning phase so the agent explains the architecture before touching code. Hand off to agent mode for implementation. Let autopilot work only after the plan is clear. Keep checking the context window so the agent is not silently losing the important pieces. When files change, review them. Then run the app or tests. If it works, iterate. If another direction might be better, fork rather than overwrite your progress. Now make it practical. In the lab, create a tiny toy feature such as a notes file summarizer or a simple Fast API health endpoint. Force the agent to produce a plan first, then implement one small slice. Your verification step is this: run the app, command, or test that proves the feature works. Then record the exact command and result in course-progress.md. The mistake to avoid: do not count generated files as success. Success is a running app, passing check, or verified behavior. The 3 takeaways are: plan before implementation, autopilot needs scope, and verification is the finish line. Lesson 7 of 18. Why agent customization matters. The official page teaches this. This lesson introduces GitHub Copilot agent customization in VS Code and the agent customizations view for consistent AI results. Here is the real explanation. Once you understand safe sessions, the next problem is repeatability. Without customization, every session depends on how well you remembered to phrase the prompt. That means the agent may follow your style once, forget it the next time, and miss project-specific rules unless you keep repeating them. The agent customizations view exists because serious agent workflows need persistent behavior. You want the editor to know the standards, reusable prompts, workflow skills, hooks, and specialized agents that belong to your project. Customization turns Copilot from a generic helper into a project-aware assistant. Now make it practical. Open the lab and inspect.github/copilotinstructions.md. Identify one rule that should always apply, one task that should become a prompt file, and one repeated workflow that might become a skill. Your verification step is this. Your checkpoint should classify those 3 examples correctly and explain why each belongs in that customization layer. The mistake to avoid: do not put every preference into one giant instruction file. Different customization features exist because different rules have different shapes. The 3 takeaways are: customization creates consistency, the view is the control center, and different behavior needs different layers. Lesson 8 of 18. Introduction to Custom Instructions. The official page teaches this. The official lesson explains how to create and use custom instructions to guide Copilot behavior, enforce coding standards, and get consistent chat results. Here is the real explanation. Custom instructions are best for always-on standards. Think coding style, architecture rules, accessibility expectations, testing expectations, security defaults, naming conventions, and team preferences. If you want every Copilot response in a workspace to respect a rule, instructions are the right layer. The official lesson includes examples like enforcing solid principles and accessibility guidelines. The important design rule is specificity. A weak instruction says write good code. A useful instruction says keep changes small, run available validation commands, avoid secrets in files, and explain verification. Instructions should reduce ambiguity, not create a wall of generic advice. Now make it practical. Add or review one workspace instruction in the lab. Make it concrete. For example, require every code change to include the verification command used. Then ask Copilot to perform a tiny edit and see if the instruction shapes the response. Your verification step is this. The result should mention or follow the instruction without you restating it in the chat prompt. The mistake to avoid: do not hide temporary task details in custom instructions. Instructions are durable rules, not a dumping ground for current session context. The 3 takeaways are: instructions are always on standards, specific rules beat generic advice, and workspace instructions help teams stay consistent. Lesson 9 of 18, Introduction to Agent Skills. The official page teaches this. This lesson defines agent skills as structured bundles that include instructions, scripts, and supporting resources. It shows how they automate workflows and reduce repeated prompting. Here is the real explanation. A skill is for a procedure. If custom instructions are the house rules, skills are the playbooks. They can include instructions, scripts, templates, references, assets, and examples. The official lesson emphasizes that skills package everything needed to perform a task into a reusable system. That matters because agents get better when the workflow is encoded once instead of re-explained every time. A README update skill can specify what to inspect, how to rewrite, which commands to run, and how to verify. A release note skill can define the changelog format, Git commands, and review checklist. Now make it practical. Pick one repeated lab workflow, such as writing a lesson checkpoint or reviewing a small diff. Draft a minimal skill outline, trigger, steps, pitfalls, and verification. You do not need to install it yet. The goal is recognizing when a workflow deserves structure. Your verification step is this. Your skill outline should include at least one exact verification step, not just instructions to be careful. The mistake to avoid: do not create skills for one-off tasks. Skills are for workflows you expect to repeat. The 3 takeaways are: skills are procedural playbooks. They can include scripts and resources, and good skills end with verification. Lesson 10 of 18, Introduction to Custom Agents. The official page teaches this. The official lesson explains custom agents as specialized roles for consistent workflows, with examples like Security Reviewer and Arcade App Builder agents. Here is the real explanation. Custom agents answer the question, who should the AI be for this job? A security reviewer agent should look for threat surfaces, risky dependencies, secrets, auth mistakes, and missing validation. A documentation reviewer agent should care about clarity, examples, navigation, and stale claims. An app builder agent might have permission to scaffold files and run tests, while a reviewer agent might stay read-only. This is stronger than putting a role phrase into every prompt because the agent definition can carry persistent instructions, tools, and expectations. Now make it practical. Design one custom agent for the lab. Give it a role, scope, allowed tools, disallowed actions, and output format. Then ask when you would use it instead of normal Copilot chat. Your verification step is this. A good custom agent spec should make one kind of task more consistent and should also say what the agent must not do. The mistake to avoid: do not create a mega agent that does everything. A custom agent earns its place by being specialized. The 3 takeaways are: custom agents define roles, role scope controls behavior, and specialized agents beat one generic mega agent. Lesson 11 of 18, Introduction to Hooks. The official page teaches this. This lesson teaches hooks as lifecycle automation for workflows, standards, and triggered actions, including examples such as formatting with Prettier. Here is the real explanation. Hooks are for event-driven behavior. Instead of hoping you remember to format, test, lint, update a note, or enforce a rule, a hook runs at the lifecycle point where that action belongs. That makes hooks powerful, but also risky if they are invisible or too broad. A good hook is narrow, predictable, and easy to inspect. For example, format changed files after an edit, run a lightweight check after code generation, or stop an operation if it touches forbidden paths. Hooks are not a replacement for human review. They're automation around the review loop. Now make it practical. Write a hook idea for the lab, such as after a lesson checkpoint is generated, verify the file still contains the required 5 output fields. If you implement it, make it read-only or low-risk first. Your verification step is this. Trigger the hook with a tiny change and confirm that it ran exactly once and produced the expected result. The mistake to avoid: do not create hooks that silently change broad parts of the repo. Hidden automation is worse than no automation. The 3 takeaways are: hooks automate lifecycle events, hooks should be narrow and inspectable, and automation still needs review. Lesson 12 of 18, Introduction to Prompt Files. The official page teaches this. The Prompt Files lesson describes reusable Markdown files that define instructions or context for chat sessions. It covers when they make sense, creating a prompt file, workspace versus user-level prompts, and examples like quizzing your code base or refactoring code. Here is the real explanation. Prompt files solve prompt repetition. If you ask the same kind of question often, such as quiz me on this codebase, generate a course checkpoint, refactor this module carefully, or review this feature against our standards, then the prompt deserves a file. Prompt files are lighter than skills. They do not need to package a full procedural system. They are reusable chat starters with enough context and structure to get consistent results. Workspace prompt files are best when the prompt depends on a project. User-level prompt files are best when the prompt follows you across projects. Now make it practical. Use prompt/course-checkpoint.prompt.md after one lesson. Then create a second prompt file for one recurring study task, such as explain this file using the agent-first pillars. Your verification step is this: run the prompt file and check whether the answer follows the output format without you rewriting the instructions manually. The mistake to avoid: do not turn every prompt into a skill. If it is mainly a reusable question, keep it as a prompt file. The 3 takeaways are: prompt files reduce repeated prompting, workspace prompts are project-specific, and use them for reusable questions, not full workflows. Lesson 13 of 18, Understanding Customization Features Together. The official page teaches this. This lesson clarifies the differences between instructions, skills, hooks, custom agents, and prompt files. It uses Copilot itself to build comparison charts, scenario quizzes, and reusable references. Here is the real explanation. The confusing part is that all customization features influence agent behavior. The clean separation is by shape. Custom instructions are durable rules. Prompt files are reusable questions. Skills are procedural workflows with resources. Hooks are automatic event-driven actions. Custom agents are specialized roles. The official lesson matters because choosing the wrong layer creates mess. If you put a workflow into instructions, it becomes always-on clutter. If you put a durable rule into a prompt file, you have to remember to call it. If you use a hook for judgment, it may act when a human should decide. Now make it practical. Create a comparison chart for the lab with 5 rows: instructions, prompt files, skills, hooks, and custom agents. Add columns for best use, bad use, example, and verification. Your verification step is this. For 5 sample tasks, choose the correct customization layer and explain why the other layers are weaker. The mistake to avoid: do not memorize feature names without use cases. The decision rule is more important than the label. The 3 takeaways are: each layer has a different shape, wrong layer creates clutter, and scenario practice makes the distinction stick. Lesson 14 of 18, Customization Features in Practice. The official page teaches this. The official practice demo uses a repo analyzer project and shows custom agents, skills, instructions, prompt files, and hooks working together in a real project. Here is the real explanation. This is where customization becomes real. A project can use instructions for general rules, a custom agent for the analyzer role, a skill for the repeatable README or analysis workflow, prompt files for recurring questions, and hooks for automatic checks. The key is not using every feature because it exists. The key is assigning one job to each layer. In a repo analyzer project, the custom agent owns the role, the skill owns the procedure, the prompt file owns a reusable request, the hook owns the lifecycle check, and instructions own the standards that should apply across the workspace. Now make it practical. Build a tiny version in the lab. Use the existing checkpoint prompt, the workspace instructions, and a one-page analyzer role spec. Ask the agent to analyze the lab README, then verify that each customization layer influenced the result. Your verification step is this. Your output should show one clear effect from instructions, one from the prompt file, and one role-specific behavior from the custom agent spec. The mistake to avoid: do not stack overlapping instructions that fight each other. If two layers say different things, the agent behavior will get inconsistent. The 3 takeaways are: use the feature. Lesson 15 of 18, using tools with agents. The official page teaches this. This lesson teaches choosing agent tools, tool sets, approvals, and sandboxing settings. It explains that tools let agents search the workspace, read files, edit code, run terminal commands, fetch web content, and call external services. Here is the real explanation. Tools are how agents act. That does not mean every task should enable every tool. The official page starts with a small task, explain how authentication works, and suggest one test. That task needs repository context, but may not need terminal access, web access, or external services. The lesson teaches a discipline. Start with the task, choose tools for the first pass, add a specific tool only when needed, decide between individual tools and toolsets, create toolsets for repeat work, limit tools for custom agents, choose permission levels, and use sandboxing for terminal work. Now make it practical. Take one lab task and create a tool plan. List required tools, optional tools, and tools that should stay disabled. Then run the task with the smallest useful set. Your verification step is this. Your results should be correct without enabling unrelated capabilities. If you had to add a tool mid-task, explain why. The mistake to avoid: do not treat tools as badges. Extra tools add context noise and expand risk. The 3 takeaways are: tools are action surfaces, small tool sets improve focus, and sandbox risky terminal work. Lesson 16 of 18, extending agents with MCP servers. The official page teaches this. The MCP lesson covers installing, using, configuring, sandboxing, practicing with, and managing MCP servers that give VS Code agents focused external capabilities. Here is the real explanation. MCP, the Model Context Protocol, is a way to expose external capabilities to agents through a standard server interface. The important word is focused. An MCP server should give the agent a specific capability, such as reading a certain data source, interacting with a tool, or querying a service. The official lesson walks through starting with a concrete server, using it in chat, deciding where the configuration belongs, learning what MCP can provide, sandboxing a local server, practicing with a second server, and managing installed servers. That sequence matters because MCP expands what an agent can touch. Now make it practical. Use notes/mcpexamples.md in the lab. Pick one hypothetical MCP server and define what it should expose, where its config belongs, what sandboxing it needs, and what approval should protect it. Your verification step is this. You can explain the difference between a normal built-in tool and an MCP-provided capability. The mistake to avoid: do not connect broad external services before you know what data and actions the server exposes. The 3 takeaways are: MCP adds focused external capabilities, configuration scope matters, and sandbox and review before trust. Lesson 17 of 18, Agent Plugins. The official page teaches this. The Agent Plugins lesson teaches installing, reviewing, using, and recommending plugins. It emphasizes browsing, trying a command, reading the manifest, sharing recommended plugins, and understanding why plugins matter. Here is the real explanation. Plugins are another way to make agent workflows repeatable and discoverable. But plugin installation should not be blind trust. The official flow is a review flow. Start with the problem the plugin solves, browse and inspect the plugin, try a plugin command, read the manifest, then decide whether to share or recommend it. The manifest is especially important because it tells you what the plugin contributes. If a plugin changes agent behavior, adds commands, or exposes tools, you need to know exactly what it is adding before it becomes part of your team workflow. Now make it practical. Choose a plugin idea, even if you do not install it. Write down the problem it solves, the command you would test first, the manifest fields you would inspect, and the criteria for recommending it. Your verification step is this. Your recommendation should include evidence from inspection and a small test, not just the plugin description. The mistake to avoid: do not install a plugin because it says agentic or productivity in the title. Inspect what it contributes. The 3 takeaways are: plugins package capabilities, manifest review is mandatory, and recommend only after testing. Lesson 18 of 18, using third-party agents in VS Code. The official page teaches this. This lesson covers starting Claude and Codex agent sessions in VS Code, choosing session types, using Claude/commands, enabling cloud partner agents, choosing permission modes, comparing results, and selecting local or cloud workflows. Here is the real explanation. The final lesson shows VS Code as a control surface for more than one agent runtime. Claude and Codex can be started inside VS Code, and each session type has a different fit. The practical lesson is not that one agent should replace all the others. It is that the editor can coordinate the right agent for the job. A local Codex session may be right for coding work with project context. A Claude session may be right for a certain reasoning or review workflow. Cloud partner agents may be useful when the task can be handed off cleanly. Permission mode is still central. Third-party does not mean permission-free. Now make it practical. Compare 2 hypothetical tasks, review a small diff, and implement a multi-file feature. Choose which agent session you would start, whether it should be local or cloud, and what permission mode it should use. Your verification step is this. Your comparison should mention task size, context sensitivity, required tools, and review strategy. The mistake to avoid: do not pick agents by brand loyalty. Pick by task shape, permissions, and verification path. The 3 takeaways are: VS Code can host Claude and Codex. Agent choice depends on task shape, and permission mode still matters. We are at the final lab plan. The reading pack includes a local lab workspace with README, course checklist, Copilot instructions, MCP notes, and checkpoint prompts. That lab is the bridge between watching and learning. A full course only works if the viewer acts after every lesson. Use the lab as a ritual. Open the workspace. Study one official page or lesson. Do one small exercise. Run or inspect the verification step. Write a checkpoint. Then move on. At the end of Foundations, you should be comfortable starting, reviewing, debugging, and shipping with agent mode. At the end of Customization, you should know when to use instructions, skills, custom agents, hooks, and prompt files. At the end of Extensions, you should know how to choose tools, MCP servers, plugins, and third-party agent sessions without losing control. Here is the capstone. Follow a 3-week pace: 6 Foundations lessons in Week 1, 8 Customization lessons in Week 2, and 4 Extensions lessons plus a capstone in Week 3. The capstone is a small repo analyzer workflow using at least 3 customization features and 1 carefully scoped tool plan. The proof is concrete. Your final artifact should include a course-progress.md checklist, 1 prompt file, 1 instruction improvement, 1 custom agent spec, 1 skill outline, 1 hook idea, and 1 MCP or plugin review note. The trap is also simple. Do not call the course complete because you watched it. Completion means you can operate the workflow and prove it. If you finish with those artifacts, you did not just watch a VS Code course. You built an operating system for safe agentic development.